Welcome viewers, in this video we will see the details about Tellegen's theorem. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic. The explanation of Tellegen's theorem, one of the theorem available in the circuit theory. First we will see the statement. In any network, the summation of instantaneous power or the summation of complex power of sinusoidal sources is 0. So if you consider any network, sum of the instantaneous power or complex power is equal to 0. The network may be linear, non-linear, passive or active and time invariant or varying, whatever may be. Either there is linear or non-linear, passive, active, time invariant or varying, the instantaneous power is 0. For instantaneous power, the theorem may be expressed mathematically as summation of B equal to 1 to B, VB, IB equal to 0. This B into I is nothing but power. Power equal to voltage into current. B is nothing but starting from 1 to B for n number of powers. Or if you add all the power in the network, that is equal to 0. That is the statement. In case of the complex power, the expression will be different. In case of complex power, where B is the number of branches in the network. For example, for complex power, the theorem may be expressed as B equal to 1 to B, SB equal to 0. What is that? SB is nothing but VB into IB star. That IB star is the complex conjugate of IB. Complex number means automatically we go real term and imaginary term. So that the star refers the complex conjugate of the IB. So in any network, the sum of the instantaneous power or complex power is equal to 0. This B equal to 1 to B means n number of networks, n number of branches. Right. The some more details available. We'll see the some more details available in the Tellegen's theorem. The above statement implies that energy must be supplied at the rate which is just equal to the rate at which energy is dissipated in resistor and stored in capacitor and inductor. So that is the meaning energy. What is the energy supplied is equal to energy dissipated. Energy dissipated means is dissipated in resistor. In case of capacitor inductor, energy is stored. So what is the energy rate supplied? That is dissipated in case of resistor, capacitor and inductor. So energy supplied is equal to energy dissipated. So that we are getting net power is 0. Thus the power delivered by independent source of the network must be equal to the sum of power observed in all other branches of the network, either dissipated or stored. So we need to understand that power delivered by the independent source of the network is equal to sum of power observed in all other branches of the network. Right? What is the power observed? That should be equal to power delivered, so that we can get the net power is equal to 0. Right? One important note is available. The branch voltages are arbitrary chosen with the only constraint that they satisfied KVL, Kirchhoff's voltage law. Right? So the net power in all the branches is 0. We are taking that this branches should satisfy the KVL. The branch current are also arbitrarily chosen with only the requirement that they are satisfy KCL, Kirchhoff's current law at each node. So this theorem states the instantaneous power or complex power is 0 in any network, whether it is time varying or invariant, linear or non-linear, passive or active, either it is normal power or complex power, the instantaneous power is 0, provided that it should satisfy the Kirchhoff's voltage law, branch voltages. Similarly, the node voltage, node or satisfy the Kirchhoff's current law, KCL, KVL and KCL. It should choose, you have to satisfy KVL or KCL, then only this statement is true. So in this video, we discuss about the details of Tellegen's theorem, statement of the theorem, mathematical expression and important points, that is power observed equal to power dissipated. in they either by resistor, capacitor or inductor. Similarly, power what we delivered should be equal to the power absorbed by all other elements, and also it should satisfy the KVL or KCL, Kirchhoff's voltage law or Kirchhoff's current law. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we will see the solved problem based on the Tellegen's theorem. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic. Verify the Tellegen's theorem for the network shown below. We need to verify the Tellegen's theorem for the network given in the problem. Now we will see the network. So this is the network given. One voltage source is available. Here one inductor, resistor, capacitor and another resistor. Here one capacitor is available. So the voltage across and current flowing, all the details are given. V1 to V6, similarly I1 to I6. And this network is given, the naming is given. P, Q, R, T, U. This is X, Y. This terminal is both are same, so that there is no name is available. So P, Q, R, T, U, and this one is X, Y. So the voltage V1, the source voltage is V1 and current is I1. This inductor voltage is V2, I2. For this branch QT, the current is I3, voltage is V3. For QR, we have capacitor, voltage is V4, current is I4. For PT, one more resistor is available, voltage is V5, current is I5. And this XY, one capacitor is available, voltage is V6 and current is I6. What is the Tellegen's theorem? Tellegen's theorem states that in any network, the sum of power, instantaneous power is equal to 0. Sum of the power means voltage into current, power equal to V into I. So the summation of V into I equal to 0 for any network, either normal power or complex power. So we need to verify that the sum of power available in this network, this V into I, is equal to 0. For that we are going to analyze the voltage. We are going to analyze the voltage for each and every loop. That should be equal to what is the voltage given. Similarly, the loop current, we are going to verify the loop current, right? So instead of power, we are going to verify voltage of each and every loop and current of each and every loop. That should be equal to 0 or that is given in the, as it is given in the value, right? So V1 is 4 voltage, V2 2 voltage, V3 2 voltage, V4 3 voltage, V5 minus 1 voltage, V6 minus 5 voltage. I1 is 2 ampere, I2 also 2 ampere, I3 4 ampere, I4 minus 2 ampere, I5 minus 6 ampere, I6 4 ampere. Now we will verify. First we will verify the voltage, right? First we will take this loop, PQ, TUP, right? In this loop, this V1 equal to V2 plus V3. The voltage what we are applied is voltage drop across the element. So we will check later. First we will analyze the circuit. V1 equal to V2 plus V3. Then if you take this loop, Q, R, T, Q. Then what is that? V3. This V3 is equal to V4 plus V5. The voltage drop across equal to sum of the voltage drop across this branch. Both are same. Q, T is same as Q, R, T. Both are connected in parallel. So that V3 equal to V4 plus V5. Then take the another loop, Q, R, T, Q. Right. And another one more loop, P, Q, R, Y, X. This loop. If you take this loop, there is no voltage source. The sum of the voltage is equal to 0. V2 plus V4 plus V6 equal to 0. Right. So the first loop, V1 equal to V2 plus V3. Second loop, V3 equal to V4 plus V5. Third loop, V2 plus V4 plus V6 equal to 0. Right. So that we will verify later. Now we will analyze. Similarly, we will analyze the current. What is this current I2? I2 is nothing but I3 plus I4. I2 is splitted into I3 and I4. What about this I4 is splitted into I5 and I6. What is this I6? I6 is nothing but I1 plus I2, right? So we will verify I2, I4, I6. I2 is nothing but I3 plus I4. I2 equal to I3 plus I4. I4 is nothing but I5 and I6. I5 plus I6. I6 is nothing but I1 plus I2. Right? So these three voltages, the voltages in three loop and current in three loops are now analyzed. We will see the expression for this. Right? First let us see whether the KVL and KCLs are satisfied. That is, Tellegen's theorem is telling some instantaneous power is 0 such that it should satisfy the KVL, Kirchhoff's voltage law and current law. First we will see the Kirchhoff's voltage law. First for the loop PQTUP, we already discussed V1 equal to V2 plus V3. V2 is given 4, V2 given 2 voltage, V3 also given 2 voltage. So that 2 plus 2 4 voltage. V1 equal to 4 voltage. Already V1 is given 4 voltage only. Right? So by analyzing the KVL, we will got V1 equal to 4 voltage. Already the given value for V1 also 4 voltage. So it's satisfied. Now similarly for the loop Q or TQ, we already discussed V3 equal to V4 plus V5. V4 is 3 voltage. V5 is minus 1 voltage because it is going down. Right? So 3 minus 1, 2 voltage. V3 is 2 voltage. So this is also given. The value of V3 is 2 voltage. The given value of V3 also 2 voltage. By analyzing the KVL, we got 2 voltage. So it is satisfied. Right? So the one more loop is available for the loop of PQ or XYP. So here the source is not available. So V2 plus V4 plus V6 equal to 0. So V2 is 2 voltage, V4 is 3 voltage, V6 is minus 5 voltage. Right? It is given in the problem itself. So 2 plus 3, 5, 5 minus 5, 0. Right? So the equation is satisfied. Hence KVL is satisfied for all three loops. Right? So we verified the Kirchhoff's voltage law for all the three loops. First loop having the source is available. So that V1 equal to V2 plus V3. In second loop, V3, the both are connected in parallel. So V3 equal to V4 plus V5. In third loop, there is no source. The total by adding all the voltage is equal to 0. So now we satisfied all three loops will satisfy the Kirchhoff's voltage law. Now we'll go to the Kirchhoff's current law. So by applying KCL, Kirchhoff's current law for the node P, Q and R respectively, we'll get the following equation. We already discussed I6 equal to I1 plus I2. That is I1 is 2 ampere, I2 also 2 ampere. That is equal to 4. So I6 is 4 ampere. So that we'll check with the given value. Similarly, I2 equal to I3 plus I4. We already discussed in the network. By diagram we already explained. So I3 is 4 ampere, I4 is minus 2 ampere. So 2 ampere. I2 equal to 2 ampere. I4 equal to I5 plus I6. That is minus 6 ampere. I5 is minus 6 ampere. I6 is 4 ampere. So minus 6 plus 4 minus 2. Right? So I6 what we got is 4 ampere. I2 what we got 2 ampere. I4 what we got minus 2 ampere. So these values are the given values also same. What we are got in this equation, that is given values also equal. So KCL is satisfied for all three nodes. Right? By applying KCL, we got the value of I6, I2 and I4 that is very equal to what is the value given in the problem also. So that it satisfied the KCL. Now we'll verify the instantaneous power. That is the important point of the Tellegen's theorem. K equal to 1 to 6. There are 6 nodes, 6 networks available. 6 branches are available. V1 to V6. Similarly, I1 to I6. Vk, Ik equal to 0. This is the mathematical expression of the Tellegen's theorem. Right? So that summation of K equal to 1, Vk, Ik equal to 0. So in this problem, K equal to number of branches, that is equal to 6. So that summation of K equal to 1 to 6, Vk, Ik. That is, we have to apply from 1 to 6. V1 into I1 plus V2 into I2 plus V3 into I3 plus V4 into I4 plus V5 into I5 plus V6 into I6. Right? So from 1 to 6 branches are available. Now we need to substitute all the values. V1 I1 4 into 2, V2 I2 2 into 2, V3 I3 2 into 4, V4 I4 3 into minus 2, I4 is minus 2, V5 I5 minus 1 minus 6, V6 I6 minus 5 into 4. So we got 8 plus 4 plus 8 plus minus 6 plus 6 minus 20, right? So by adding all this value, what we got is 0, right? See this 6 minus 6 got cancelled. 8 plus 4 12, 12 plus 8 20. This is minus 20 is there, so it got 0, right? So that is the important statement of the Tellegen's theorem. Instantaneous power in any network is equal to 0, and also it should satisfy KVL and KCL. This already we verified. If this network satisfies the KVL and KCL, and also it satisfied the instantaneous power is 0. Hence the Tellegen theorem is proved for the given problem given. So in this problem we verified the Tellegen's theorem, that is we verify with KCL, KVL, then instantaneous power. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the solved problem based on the Tellegen's theorem. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Verify the Tellegen's theorem for the circuit shown below. We need to verify the Tellegen's theorem for this circuit. The Tellegen's theorem is nothing but for any circuit the instantaneous power, the sum of instantaneous power is equal to 0. That is the statement of the Tellegen's theorem, and also the circuit should satisfy the KVL and KCL, Kirchhoff's voltage law and Kirchhoff's current law. So in this circuit we need to verify this power delivered by this source is equal to power absorbed by these elements, resistive elements. We need to verify, right? We have to identify what is the total power delivered by this source. What is the total power absorbed by this resistor? Well, both are equal, that is power delivered equal to power absorbed. So in order to find the power, we need to identify what is the voltage across each and every resistor. There are 4 resistors available, R1, R2, R3, R4. The voltage across R1 is V1, R2 is V2, R3 is V3, R4 is V4. And the current is the total current, first current is I1. Then it is split into I2, I3, I4 with the resistor R2, R3 and R4. So we need to identify, we need to find the value of V1, V2, V3, V4. Similarly I1, I2, I3, I4. From that we need to find what is the voltage drop, power across the resistor, and what is the power delivered by the source, right? So in this circuit, by analyzing, it is clear that these 3 resistors are connected in parallel. R2, R3, R4 are connected in parallel, and also it is given R1 value is 1 ohm. This R1 is 1 ohm. R2, R3, R4 is 2 ohm. All the resistors having same value, 2 ohm, and this also 2 ohm. Then what is that? The voltage drop across R2, R3, R4 are equal because it is connected in parallel, and also values are equal. Similarly, the current flowing through the resistor R2, R3, R4 also equal because of same value of resistor. That is I2, I3, I4 also equal. I2 equal to I3, that is equal to I4. V2 equal to V3, that is equal to V4, right? Now we'll find the values. First we'll find the total resistance of this circuit. What is the total resistance of this circuit? These 3 are connected in parallel, that is in series with the R1, right? So first we'll find the total resistance. Then we'll find the total current. From that we can find the voltage V1, V2, V3. Then we'll find the I1, I2, I3. From that we can find total power, right? Now we'll go to find the total resistance of this circuit. Let the first calculate the various currents and voltage drop. For that, first what we need? Total resistance or parallel. That is, these 3 resistors are connected in parallel. 1 divided by 1 by 2 plus 1 by 2 plus 1 by 2. That is 1 divided by 3 by 2, that is 2 by 3, because all the values are equal. If it is all the values are equal, we can use this formula. 1 divided by the resistor value. 1 divided by 1 by R value. Right? So that it is 2 by 3 ohm. Right. So then what is the total resistance R total? R total is nothing but 1 plus Rp. Right? The resistor R1 equal to 1 ohm, then the parallel resistor. So 1 plus 2 by 3, that is 5 by 3. The total resistance of the circuit is 5 by 3. Right? So the first resistor R1 is 1 ohm, that is parallel with this, series with this parallel resistor. So that it is 5 by 3 ohm. This one is nothing but the resistor R1. This is R2, R3, R4. All values are equal. So from that we can find the source current, that is equal to I1. Both are equal. Now we will refer the diagram again. This is R1. R1 value, that is value is 1 ohm. This R1 is series with this parallel combination. So that 1 plus 2 by 3. Similarly, the source current is equal to current I1. Both are same. The source current equal to IS equal to I1, because R1 is connected in series with the source. So that is Vs by RT. Vs is 100 ohm, 100 voltage. The total resistor is 5 by 3. So it is 100 into 3 by 5, that is equal to 60 amperes. So the voltage, the source current as well as the current I1 is 60 amperes. From that we can find V1. V1 equal to I1 R1. I1 is 60 amperes. R1 is 1 ohm, 60 voltage. Right? So the I1 is equal to 60 amperes. V1 equal to 60 voltage. And also source current also 60 amperes. Now we will find the voltage drop across each and every element. Vs equal to V1 plus V2. In a closed loop, Vs equal to V1 plus V2. We will refer the diagram. So this is the closed loop. The voltage 100 what delivered is equal to voltage drop across R1 and R2. So 100 equal to V1 plus V2. Vs equal to V1 plus V2. The voltage what we applied is equal to voltage drop across R1 and R2. Based on that, Vs equal to V1 plus V2. From that, V2 equal to Vs minus V1. Right? Vs is 100 voltage. V1 what we calculated is 60 voltage. So 100 minus 60, 40 voltage. So V2 equal to 40 voltage. We know that this V3, V4, V2 all are equal. We already discussed all the resistors are connected in parallel and also the resistor values are equal. So the voltage drop across R2 is V2, that is equal to V3, V4. Voltage drop across R3 as well as R4. All are 40 voltage. Since the voltage is same across the parallel combination. Right? So now we calculated V1, V2 as well as V3, V4. Right? V1 is 60 voltage. V2, V3, V4 is 40 voltage. Then I2, I3, I4, that also equal. That is the total current. The total current is 40 divided by 2 is 2 ampere. Right? The 40 voltage is available across the V2 divided by the resistor is 2. I equal to V by R. V is 40 voltage, R is 2. So 20 ampere. The 20 ampere is flowing through the current, each and every resistor. I2, I3, I4. And also the total current is 60 amperes. So there are 3 resistors available. So equally divided, 20, 20, 20. Right? Current across R2 is 20 ampere, R3 is 20 ampere and R4 is 20 ampere. The 60 ampere is 3 divided by 3, equally divided by 3, so 20 ampere. That also another calculation. Otherwise, I equal to V by R. V is V2. The I2 is V2 by R2. 40 by 2, 20 ampere. So now we can find the power delivered by the source. Vs, Is. Vs is 100 voltage. Is what we calculated? 60 ampere. That 60 ampere only divided into 20 voltage in 3 resistors. So it is 6000 watts. Power delivered by the source is 6000 watts. Now we need to verify the voltage drop across each and every resistor. Power drop across each and every resistor should be 6000. That is the Tellegen's theorem. Power delivered equal to power absorbed. So that net power is 0 in any network. Sum of power in any network is 0. Now we calculated V1, V2, V3, V4, I1, I2, I3, I4. Then we calculated the power delivered by the source. Now we'll see power absorbed by the resistors. So total power dissipated by the resistor equal to, there are 4 resistors available. So V1, I1, V2, I2, V3, I3, V4, I4. Right? This is the first resistor connected. Then these 3 resistors are connected in parallel, R2, R3, R4. So we know the value of V1, V2, V3, V4 as well as I1, I2, I3, I4. V1 is 60 voltage, I1 is 60 ampere. Right? V2 is 40 voltage and V3, V4 also 40 voltage. Similarly, I2 is 20 ampere, I3, I4 also 20 ampere. Right? The voltage across R2, R3, R4, similarly current flowing through R2, R3, R4 also equal, 40 into 20. So 60 into 60, by simplifying all this, what we got? 6000 watts. Right? So this power dissipated also is 6000 watt. Earlier we calculated power delivered by the source also 6000 watts. So as power delivered is equal to power dissipated in the circuit, the Tellegen theorem is said to have been verified. Right? So power delivered as well as power absorbed is what we calculated are equal. So that the Tellegen theorem is verified. So in this problem, we verify the Tellegen's theorem. First we calculated the voltage across each and every element, current through each and every element, then power delivered by the source, then power absorbed by the each and every element. If both are equal, we observe that both are equal. So the Tellegen theorem is verified. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.